Okay, time for lesson 4.2. 4.2 is one that actually comes up quite often on your AP exam. So we need to make sure that we understand what's happening, what's going on. This is position, velocity, acceleration. Sometimes we refer to that as PVA. Okay, PVA. That's going to be position, velocity, and then acceleration, which I don't have room for, so we're just going to write Excel. Okay. All right, so one important application is calculus in particle motion, meaning you have a particle that is moving left and right on a straight line, like an x-axis. Sometimes it can even be a particle moving up or down on like a y-axis. Okay, so they're going to talk about the position of this particle. They're going to talk about the velocity or speed of this particle, and then they're going to talk about the acceleration of the particle. So the three things that we're going to talk about today are position, like where is it? Okay, that is usually denoted with an S of t or an X of t. S of t or X of t. Then you're going to have velocity. And velocity is the derivative of position. Velocity we're going to note with v of t, and it is the derivative of position. And then acceleration, which is going to be a of t, which is your derivative of velocity, therefore making it the second derivative of position. So it's p, then v, then a. Position is your original equation. The derivative of that is velocity. The derivative of velocity is acceleration. Before we go any further, real quick, you know this, but just to remind you, remember that speed and velocity are not the same thing. Okay, they refer to the same thing, but speed is always positive. Velocity will have a sign. Velocity will be positive or negative. Speed is always just positive. I can drive home backwards. I still went 30 miles an hour. I just went backwards. Okay. My velocity, though, has a sign, and that sign will indicate which direction it's going. So if we're talking about something that's moving horizontally on an x-axis, a positive velocity would mean it's moving to the right. A negative velocity would mean it's moving to the left. If you are talking about something that's moving up or down, then up would be a positive velocity, down would be a negative velocity. Okay, so velocity has a sign, speed does not. Okay, in calculus AB, meaning like first semester calculus of college, all motion is considered rectilinear, meaning motion only happens along a straight path, either horizontally or vertically. We're not going to talk about motion on a curve or some funky graph. It's literally going to be motion on a straight horizontal line or a straight vertical line. Okay, questions involving motion are common on the AP exam, which I started your lesson with. I told you that. We will need to be able to use these equations and take derivatives as needed to answer questions involving motion. To answer questions involving particle motion, we will need to be able to decode these questions into math equations considering these phrases. So looking at this chart, which is a great chart. I usually don't like the charts, but I like this one. Okay, so they're talking about a bug walking along a straight horizontal path, right? Sometimes he's moving right. Maybe then he turns around and goes back left. I don't know. Okay. But if they're asking you to find when the bug is stopped, the mathematical translation to that means we're looking for when the bug's velocity is 0. Stopped is directly related to velocity being 0. Okay, that means its speed is 0, its velocity is 0. So how do we solve that? We set the velocity equal to 0 and solve for t. We're solving for the time when the bug is stopped. Okay, if we're trying to find the time where the bug is moving to the right, as I said earlier, right would mean your velocity is positive or greater than 0. So if we're trying to find where an equation is greater than 0, we're going to set our velocity equal to 0. Then we're going to solve for t. And then we're going to do a sign chart. So sign chart, if you remember, is like where you put your zeros on there and then you test this section, you test this section, you test this section. Maybe it's positive, negative, positive. If you're looking for where velocity is positive, then your answers are these two sections. Okay, we've done that before. This should be familiar to you. So a sign chart, that's what I'm talking about when I say sign chart. Okay. If the bug is moving to the left, that means your velocity is negative. And we're going to do the exact same thing, except for we're going to look for the negative parts of the sign chart. If we're trying to find when does the bug turn around? Well, turning around means it would go from either moving to the right and change back to moving to the left, or change from moving to the left to moving to the right. So we're looking for where our velocity changes signs, like where it goes from positive to negative, negative to positive. And guess what? We're going to do the chart again to figure that out. Just because it stops doesn't mean it turns around. So I know some of you might be thinking, well, can't we just find where the bug stops? Because it has to stop and then turn around and go from left to right. Not necessarily. It could stop. It'd be going right, stop, and then continue moving right. Like just because it stopped doesn't mean it's going to turn around. Okay. Speeding up and slowing down. This one is not as common sense. Okay. For things to be speeding up or slowing down, you have to look at both their velocity and their acceleration. If it's velocity at that time and acceleration at that specific time, if the signs are the same, like they're both positive, they're both negative, then it's speeding up. Okay. If you check the velocity and the acceleration and their signs, one's positive, one's negative, so their signs are different, then it's slowing down. It doesn't have anything to do with acceleration. Okay, it's not just like acceleration positive, acceleration negative. It has to do with, are your velocity and your acceleration doing the same thing? Are they both positive? Are they both negative? Or are they doing different things? One positive, one negative. So you're going to check for both of these, the signs, positive, negative, on your velocity at that time and acceleration at that time, and then make your decision. Okay, so that's not necessarily all of the things that you're going to be asked, but it's a good start. It's a good start. So the math, and again, this is calculus and it happens all the time. The math isn't the hard part. The deciphering the problem and then making sure that you're doing the right thing to solve it is the hard part. Okay, so let's go to example 1. 4 times 0 to 8. The position of a bug moving along an x-axis is defined by this equation. So this is position. The position of a bug is this. So they're telling you this is your formula for position. So if I want to know where the bug is at time 5, I plug in 5. If I want to know where the bug is at time 6, I plug in 6. But this is an equation for the bug's position from any time 0 to time 8. Okay? So the first question, what is the position of the bug when it first starts walking? Okay, so we're asked for position, so we're going to use the position equation. And I'm asked specifically when it first starts walking. So what have they given me? What they've given me that I'm talking about time 0. First starts walking, that tells me time 0. So all I had to do is go to that equation because this is a position equation, and I'm plugging in 0 for all of my t's. And if I do that, I'm going to get a third times 0, 7 halves times 0, 12 times 0 plus 2, which is just going to be 2. So the bug's position when it first starts walking is at 2. So think about like a number line. That means if you're on a number line and your bug is walking on this number line, then here is where your bug starts. We don't know if he's going to move to the left, to the right. I don't know, but I know he starts there. Okay. At what time is the bug stopped? Stopped means you're looking for where the velocity is 0. We don't have an equation for velocity. We can find one though, because I know velocity is going to be the derivative of position. So all I have to do is do the derivative of the position function that they already handed me. 3 times a third is 1 t squared minus 7 t plus 12. There's my equation for velocity. So now I need to take that equation and I'm trying to figure out where this equation, t squared minus 7t plus 12, is equal to 0. I'm finding where that velocity is equal to 0. It is factorable. That's going to be t minus 3 and t minus 4. So we're talking about at times 3 and 4. My bug is stopped. Okay. On what intervals is he walking to the left? Okay, well, we already did part of this because here's what I know about left. I need to look for where my velocity is negative. Okay. In order to do that, I need to make a sign chart. What goes on my sign chart? Where my bug is stopped goes on my sign chart because that's going to tell me where it switches from left to right, right to left, because it has to stop in order to do that. So 3 and 4 are going to go on my sign chart. I am using this equation, but it's easier to use it in factored form, right? And we're going to plug in numbers from each of these 3 sections. We really don't have to do all 3. We just have to do 1 because we know that they're all of a multiplicity of 1, so it's going to flip every time. So if I plug in 0, I'm going to have 0 minus 3 times 0 minus 4. That's a negative times a negative, which means at 0, I'm going to be positive. And I know it's going to flip-flop because I have a multiplicity of 1, and then it's going to flip-flop again because 4 has a multiplicity of 1. I am looking for where this is negative. That's in this section here, which means from 3 to 4. You can write 3 is less than x is less than 4 in inequality notation, or you can write 3 to 4 in interval notation. Either one of those is correct. Whether you write inequality or interval doesn't matter to me. I will probably write interval because it's less writing and I like it better. But for some of you, you get confused because it looks like a point. Totally fine, doesn't matter to me. Okay, but it's 3 to 4. Why do we not include 3 or 4? Because it's not moving left at 3 or 4. It is stopped at 3 and 4, so we don't include them. Okay? All right, again, pause, rewind, whatever you need to do. I'm going to move on to the next question, okay? Example 2, new given information. So last time they gave you an equation, this time they're just giving you a graph. And it's when you are just given a graph, you need to be very careful that you pay attention to what this is the graph of. Okay, this is the velocity of a bug from times 0 to 13. So you are given the graph of velocity, not position. Remember, it goes position, then velocity, then acceleration. So that means this is velocity. This is the derivative of position. Okay? So first couple things. A, find V of 3 and V of 11. This is a V graph. So V of 3 just means going to 3, finding the Y value at that point, and V of 3 is 6. V of 11 just means going to 11, finding that point. What is the Y value? It's negative 2. Okay, so since this is a graph of V, all we are finding is the Y values there. Then on B, it asks us for acceleration. Remember, acceleration is the derivative of velocity. So if we're finding accelerations, that means we're looking for the slopes of velocity. Okay, so A of 1 means I am finding the slope when x is 1. So that's right here. The slope looks to be up 2 over 1, so positive 2. A of 5 means go to where x is 5, which is right here. Find the slope. It's horizontal. The slope is 0. And A of 9 means go to where x is 9. Find the slope there. And it looks like the slope is 1, 2, 3 over 1, so negative 3. Continuing on with that same graph, now they're going to ask you some more questions about it. It says, at what time does the bug turn around? At what time does the bug turn around? Okay, so turning around means that it will have changed from going from the right to the left or left to the right, which means your velocity needs to change signs. Okay, your velocity needs to change signs. So if we're looking at this graph, Remember, this is the graph of velocity. That's a big deal that you remember. This is the graph of velocity. So where does it change signs? Velocity is positive, all of this. It's negative here. So where does it change from velocity being positive to velocity being negative? Right here at 9. So at t equals 9, give a reason, because velocity changes from positive to negative. Okay. On what interval does the bug have a negative acceleration? All right. We don't have an equation. All we have is a graph. So let's remember, acceleration is the derivative of velocity, which is the same thing as the slopes of velocity. And we are looking for where these slopes are negative. So we're looking for where the slopes of this graph that they have given us are negative. So if we go back up to this graph, we're looking for where the slope is negative. This right here is the only section of my graph that has a negative slope. Okay, slope here is positive, slope here is 0, slope here is positive. So that's the only place where we have negative slopes, and we need to say what x's that goes from, and it looks like it's 7 to 10. So again, you can write that, you can write that as an interval. 7 is less than x is less than 10, or you can write it in, in an inequality or an interval notation. Okay? All right, next, how many times is the speed of the bug equal to 2? Now be careful, because remember, speed is not exactly the same thing as velocity. Speed doesn't have a sign. So when the velocity is 2 or negative 2, that's when the speed of the bug is 2. So, well, speed is 2 when velocity is either positive 2 or negative 2. So we're going to go up to our graph and we're going to say, okay, here is a velocity of 2. That happens here and it happens here at 1 and 8 point something, right? That's like 8.3 or 4. Okay. It is negative 2 here and here. So I've got 4 spots where the speed would be 2, because these 2 spots are where velocity is positive 2. These 2 spots are where velocity is negative 2. Okay, so I'm just going to list those 4 x's, which I'm going to estimate. Well, it's obviously 1. I'm going to say that 1 is like 8.3. And then on the bottom, we've got 11, which is right on the intersection. And then I'm thinking about 9.6. Okay. So like I said, the math, like if you look at the math that we're doing, there's hardly any math. Like it's not that hard. It's just like understanding the relationship between position and velocity and acceleration and going right and going left and changing direction, like all these different things that you have to think a little bit more critical thinking to figure out what you're actually trying to find. Okay. All right, example 3. Notice that it is calculator active. That means you're allowed to use your calculator. That means that this gross, yucky equation over here, we don't have to do that derivative by hand. We can do that derivative in our calculator. Great. We can put this graph in our calculator and then use like intersect buttons and zero buttons and things of that nature if we need to. The fact that it's calculator means that we don't really have to do anything by hand. Okay. All right. So here's what we got. From time 0 to time 2, a bug is moving along an x-axis with this velocity. So again, here is our graph of velocity. That may or may not be given. If it's not given, you can certainly see it on your own graph on your calculator. If I were you, I would change your x min and x max to be similar to what your area is. So if it says 0 to 2, I might not do 0 to 2, but notice how they've done like -0.5 to about 2.5. That way you can see a little bit past what your actual graph is. Okay. Anyway, here we go. So let's find the acceleration at 0.7. Okay. So if you're just looking at the graph, that means, okay, here's like 0.7. That means I'm supposed to be finding the slope of that at 0.7. I'm not going to do that with my eye, right? That's not something I'm just going to be able to look at my graph and say, oh yeah, the slope is whatever there. I'm not. I'm going to have to use algebra, calculus. Here's what I know. I have a formula for velocity. Acceleration is the same thing as the derivative of velocity. So if I'm trying to find acceleration at 0.7, that's the same thing as the derivative of velocity at 0.7. So I'm going to go to my calculator and I'm going to do n-deriv on my calculator of that equation at x equals 0.7. So if I do that on my calculator, I have already done it, so I'm going to save you some time. If you want to do it on your own, pause me right now and then make sure you get the same thing. I got negative 0.921. Okay, and it doesn't give me units. If it doesn't give you units, then you are not expected to put units on your answer. So that's the first part of my answer. Find v prime of 0.7. Then it asks, is the bud speeding up or slowing down at this time? Okay, speeding up or slowing down was on that chart that I gave you. Speeding up and slowing down has to do with velocity and acceleration and whether their signs are the same or whether their signs are different. So we already know velocity is negative. We know acceleration. That is acceleration, not velocity. We now need to find velocity at 0.7, which means we're just going to plug in 0.7 to this equation that was given because that is the velocity equation. And we're going to see whether it's positive or negative. I've already done that math for you. It's negative 0.318. So because both of these are negative, that means that my bug is speeding up because they're the same sign. So my bug is, where am I going to write my answer? Speeding up because, and if it asks for justification, you have to do justification because velocity at 0.7 and acceleration at 0.7 are the same sign. All right, moving on to B. Find any values from 1 to 2 when the bug is at rest. At rest means that our velocity is 0. So if we're looking at the graph between 1 and 2, are there any times where my velocity is 0? Yes. Here and here. I'm not going to guess those. I'm going to use my calculator and I'm going to use the 0 button on my calculator to find those two spots. So I'll pause me if you want to. If you don't and you know how to do that and you just want the answer, the two times where that happens is 1.225 and 1.801. You're literally just using your calculator to find the zeros. That's it. The whole point of that problem is that you understand that bug at rest means velocity is 0. Okay. All right. Find the open intervals from 0 to 2 when the particle is moving to the right. Moving to the right is what they need you to understand. Moving to the right is where your velocity is positive. This is a graph of velocity. Velocity is positive when it's above the axis. It's negative when it's below the axis. We're looking for positive, which means we're looking for where it's above. You just found those two red points. So your interval is the interval from 1.225 to 1.801. Okay. Last one on this problem. Find the acceleration when the velocity is -1. Okay, we can't find the acceleration until we know at what time we're looking for. So the first thing you have to find out is what time is the velocity -1. So we're going to take that velocity equation, which was t squared sine of t cubed minus 1.5t. and we're setting it equal to -1. Remember, this is a calculator section. So you do not have to solve that by hand. Okay, you are going to use your calculator to solve it. How do you use your calculator to solve this? There's a couple ways you can do it. You can use your chart and like your XY chart and find where Y is -1. Or you can, what I would do is I would move the 1 over. So +1 equals 0. I would graph this and then I would find the zeros. Simple as that. And when you do, you're going to get that the only one that lies in this interval is 1.837. Again, if you want to do that on your own, pause me, come back, make sure you get that. So this is when the velocity will equal 1. Now I'm looking to find the acceleration at that time. So I need to know the acceleration at 1.837. I don't have a formula for acceleration, and you certainly don't need to find one. That's a gross formula. All you're going to do is you're going to go to your calculator and you're going to do the derivative of that velocity equation at 1.387. And you should get -28.874. And again, no units given means no units are expected in your answer. Okay. Last page of notes. For example 4, we have a chart, and it's for 0 to 8 seconds, and you've got a particle P that's moving along an x-axis. You've got the position of P, the velocity of P, and the acceleration of P given in this table. No equations, no graph. They're literally handing you the positions, the velocities, and the accelerations at these specific T's. Okay? Is the particle moving towards or away from the origin at time 4? At time 4, are we moving towards or away from the origin? The origin being 0. We're on a number line. So that's not 0, 0. That's an XY plane. Origin on a number line is just 0. Okay? Well, in order to do this, we need to know its position and its velocity, because we need to know where it is and then which direction is it going. Okay, so we need to know its position at 4, which in this case, they use x of t for position. So x of 4, its position at 4. And according to the chart, here's 4, the position is 6. So my position at 4 is 6. So just thinking about what this looks like, I'm on a number line. At time 4, I am at a position of 6. Okay, so this is where he is. But I don't know whether he's moving to the right or to the left. I don't know. Zero's over here. There's the origin. Is he moving away from the origin and going right? Or is he moving towards the origin, moving left? Only way I'm going to know that is if I see the acceleration. I'm sorry, the velocity of 4, because velocity tells me left, right. So according to my chart, the velocity at 4 is -1, which indicates that from his position, which is here at 6, he would be moving left, which means he would be moving towards the origin. Okay, because he was at a position of 6 and then moving left. B, is the particle speeding up or slowing down at 7? Speeding up and slowing down means we need to know the velocity and the acceleration. If they have the same signs, they're speeding up. If they have different signs, they're slowing down. So at 7, that's this column. Velocity is -4, acceleration is -3. So velocity at 7 is -4, acceleration at 7 is -3. Because they're both negative, we are speeding up at t equals 7 because v of 7 and a of 7 have the same signs. Okay, use the data in the table to approximate the velocity of P at 2. Velocity of P at 2. We don't have 2 as an X, right? It's not a given X. We only have 1, 3, 4, and 7. So if I'm looking for the velocity at 2, 2 would obviously be right here in between those two. And if I'm looking to find velocity, then I'm going to do the rate of change of the two positions next to it. I'm not doing the rate of change of velocity. The rate of change of velocity would be acceleration. If I want to find velocity, I'm doing the derivative of position or the rate of change of position. Okay, so I'm going to take those 2 points, which were 1, 2, and 3, 8. And I'm going to do y minus y over x minus x, which is 6 over 2, which is 3. And I need to put units because they give me units. So that's going to be meters per second. Throwing in some old stuff from several lessons ago, several chapters ago maybe. Is there a time C between 1 and 7 where the velocity will equal 0? Is there a time between 3 and 7? I'm sorry, 1 and 7. So is there a time where the velocity will equal 0? Yes, absolutely. It's going to happen right here somewhere, right? In between positive 2 and negative 1. It has to cross 0. But we can't just say that. We got to give a calculus mathematical reason. That's IVT, intermediate value theorem. So yes, because V is differentiable, therefore making it continuous, there will IVT guarantees, and you have to say IVT, there is, or there will be, a velocity equaling 0 between, and you can say between any of them, but I'm going to say between 3 and 4. Because V of 4, no, wait, which one's bigger? Yeah, V of 4 is less than 0 is less than V of 3. That's a review problem. That's an IVT review problem and knowing how to write your IVT statements. That was a couple of tests ago. Here we go again. That's calculus. It never goes away. Last problem of the day. Okay. 4, 5 to 8 seconds. Particle Q. Different particle. Not all of this is particle P. Okay. This is all for P. Notice P, P, P. Those are all for P. So now they're saying there's a second particle. A second particle Q moves along the same axis, and the position of particle Q is this equation right here. At time 7, are particles P and Q moving toward or away from each other? Explain your reasoning. Okay, so you can pause me for a second if you want to try to figure this out, but I'm running out of time, so I need to go. You're going to need to know 4 things, really. You're going to need to know where P and Q are. So what are their positions at time 7? And then you're going to need to know what direction they're moving. So that's 4 things. You need the position of Q at 7, the position of P at 7, and then the velocity of Q at 7 and the velocity of P at 7. And then we're going to kind of draw a picture and see where we're at. Okay. So according to the top, which is the easiest part, your position of P at 7 is 5, and your velocity of P at 7 is -4. Okay? We'll come back to that in a second. Our position of Q at 7 would be just plugging in 7 to this equation. And when I do, I get 3. And my velocity of Q at 7 would be doing the derivative of this and plugging in 7, of which I'm going to get 6. So let's take a look at what that means. Think about your line. So I've got P, which is at 5. So P is at 5, and it's moving to the left because It's a negative velocity. So it's at 5, but moving left. Q is at 3, and because its velocity is positive, it is moving to the right. So are these moving toward each other or away from each other? They are moving towards each other. And your explanation would literally just be to write out what I just said, which I'm not going to do. Okay. But your explanation would be because, this is at 3 moving right, P is at 5 moving left, therefore they're moving towards each other. Okay. These came straight from the chart above. These came from using the given equation right here. 3 came from plugging in 7. 6 came from plugging in 7 to the derivative of that, which you could do in your calculator or by hand. Okay. All right. And I'm done. All right. Homework is due on Monday for both 4.1 and 4.2.